So what can you expect from this session? So we have many available resources on our community website, and we sometimes realize when we talk to clients that not all of them are familiar with the resources that are available. And we're going to take a look at some of the solution and show their applications. And it's not all of them are in the community, so some of them are also support requests or just things that we learned from implementation projects, and we want to share them as well in the course of this masterclass. So what we're going to look at today is querying XML for multi-value results, using our upsearch stored procedure to emulate the SQL merge command. We're going to take a look at how to pass key value pairs as parameters to stored procedures, create our own regex replace stored procedure, even though there is one in place. We still want to take a look at how to use JavaScript in procedures. Take a look at our util schema, because that is constantly changing and there's interesting stuff in there. And I would just want to give you some examples here. We're going to take a look at how to move tables across servers and also how to backup tables from the analytical storage. Picking one example of a stored procedure to create a date access for you. Then take a look at dealing with materialization tables and how to drop them and how to find the latest stage, things like that. And also finding recommended optimizations without a schedule, because you might be working with data that's not up to date. And so we can implement some data quality check there. And also the optional joins is kind of also a highlight that we're going to take a look at. All right, so let's get started with our community page. There's two links here when you get the presentation. I mean, it's also pretty clear where these are located. And there's two parts of it. So the community is actually a place for us where we do our announcements, but it's also something for the user posts. So it's actually something where you can create your own posts if you have nice things created that you can just share here. We have a help center where we can create our own articles. That's basically done by the DV staff and not by users. And as I said, we encourage you to post your own interesting solutions in the forum. And there's, besides the forum where you can post your stuff, there's feature requests. That's pretty much what it says. So we're also going to take a look into that, how people are, if they want to see a new feature for data virtuality, you can request it there. You can also get a reply if this has already been implemented or on the roadmap, and eventually all of them will be answered. And the connector updates is a very important section. And I encourage you to subscribe here, because there's whenever there's changes in our connectors, we would publish them here, but it's also changes on the REST API side, so not on our side, that you need to consider. So it really makes sense to subscribe there. So if you're logged in, if you're using our support page anyway, then you already have the credentials and it's easy to just click there and subscribe. And finally, the announcement will be about our new releases. So for each minor release that we're pushing out, we will show you what we changed there. So it really makes sense to stay on top there of the information and get information about the new releases, and also important announcements if something doesn't work. For example, BI tools, we had that one time that you need to work around to continue working with the latest version of a BI tool. All right, so to summarize this, please share your stuff in the forum and subscribe to all the other stuff. All right, so let's get to our first example, and that will be XML multi-values. All right, we got the community link here. So this is actually where this whole article is located. And as I said, people might not be aware of it. And it might also be that you probably are getting an error message and cannot directly connect to this article, the error message that you're getting. So this problem can occur when you're using our XML JSON wizard. You will get this error message when there is a specific structure. And this structure, I basically cut it out here, includes the attributes here, as you can see, on the same level. And the question is for us, how can we put this into a table structure? And we don't know. Should it be new lines? Should it be no columns? So our wizard cannot deal with this. So to illustrate this, let's take a look at this. Let's jump into our studio. So the first thing I did here, I created a file source. And this one just points to my path, and I have XML and JSON files in there. The whole thing is also valid whenever you are working with REST API. So if you're using the generic web connector, the XML and JSON problems will be exactly the same, and you will also use the same kind of wizard. All right, so we got our file source. Now let's get started with our JSON query builder here. And let's pick the file source. Let's use our file XML source. And let's browse for the first example that would be data01.json. And let's apply it. You don't see the error message yet. You can take a look at the row configuration. You can take a look at the at this source data preview here. And let's get back to our row configuration, and let's actually use this other one here. Let's use this one, apply again. Here we actually now see these attributes down here that are the source of the problem. Let's take the place where we want to go in. That would be data, so I double-clicked on it. And now we can actually see that it's doing a good job for now, picking these elements. But as soon as I click on attributes, that's exactly the error message that I was talking about. And now we want to take a look at how to still be able to query this kind of XML and JSON. But we cannot use the wizard for this, so let's take a look at the possible solutions for it. All right. So there are three approaches that are also mentioned in the community article, and let's go through them one by one. So the first one would be indexed path expression. Let's jump to our studio again. And let's take a look at this multi-valued XML, and let's go through it step by step. So first, we just want to select the data, right? So here we're just getting the information from the file system about this data01.json file. So I'm just going to run it here. And we can see this will show us where the file is located. And the contents of the file actually are listed here as well, but it's a binary large object, so we cannot take a look at it. And some other stuff that might be interesting for you as well. So if you're processing JSON, XML, or CSV files, you can use this creation date, for example, to find the new ones that have been created today and only get to them. All right, go to our next step here. And now we are using the toChars function to actually read the document itself. So now we see the content of the file, and down here we see the attributes that are the kind of our problem. Next one would now be the first solution that I'm talking about, and that would be the indexed path expression. So until here, it's basically clear because we just took a look at this. And now we are using our XML table function And this is including JSON to XML. So what's internally happening whenever we are processing JSON, we are converting this to XML internally and then are using the XML table function on top of that. And here we are looking at these three attributes. We are addressing them directly and are getting first element, second element, and third element as a result. So let's take a look at this. So you can see we were able now to create this specific part of the JSON by addressing the elements, and the disadvantage here is immediately visible. It's only addressed directly, right? If we have a fourth element, it will not show. We actually have to know in advance what, which number of elements is there. So this is one approach, but it's not an approach that is really entirely possible. So let's go for our next approach, and that would be using two XML table function calls. So as we can see here, there's a first one and a second one, and we're actually, since we are selecting from them and using comma here, we are creating a join between them. And the trick here is basically that we're using XML table on exactly this attributes part. So we're using a table on top of a table. So that's an internal table we're looking at. And let's run the whole thing. And we can see now it's not columns, but the results looks a little bit different here. The attributes are actually in rows. We could still get them. And here we are not limited anymore to the number of the elements. So if it's one element, it will show exactly as if it were 10 elements. There's another problem still, since this whole thing is a join, and we are using these second table here as the right side of the join. If there are no attributes down there, we will also miss the other part of the query. So we might miss out on some lines here. So that's the disadvantage. The advantage is, as I said, that you can have multiple elements. You don't need to know the number in advance. All right, now let's take a look at the third option. That's the array approach. And now we actually are using this array get function, and we are passing the attributes as a string array to our query. And this one is, from my point of view, is the preferred one to use. So let's take a look at how this turns out if we run it. And you can see here, now we were able again to have them in one row. We still needed, of course, to put the query on top of it. Right, but still, this is, from my point of view, the preferred approach, but all of them are valid with their advantages and disadvantages. And now we can quickly go through the to this data2.json, which contained more attribute rows down there. So let's take a look at the result first here. And we can see here there's a second entry, and down there are included attributes, a couple of them, and let's take a look how these solutions are performing now. With the indexed path expression, the first solution, we can now see that this nicely turns out. Even though there is less elements, we have a null result here. So this is kind of passing the test, but a fourth element we wouldn't get here. Now let's take a look at this multiple XML parsing with the other function, with the other file. And this is what's expected. And you can see here that the ID column, this 4 ordinality that where we're using here, this ID column on the left-hand side created one row for each, and this ID column returns an increasing number, and we can actually see this in our result here, that there's a first row, there's a second row, and a third row. And now finally to the array approach for the larger file, we can see all the elements. Basically the same result as the first one, but it's not prone to exclude a fourth element if there is one. So we are not missing this element. All right. So Carlos, were there any questions up to now about this?
None at the moment.
All right. Then, yeah, go ahead. If you have any questions, you can post them in our Q&A. I hope it makes sense for you. And let's jump to the next topic here. And this was actually a request that we recently got again. So we created a community article on this already a while ago. And probably some guys of you who are familiar with some SQL dialects. So for example, I know that MySQL has this and Microsoft SQL allows this, this merge into, right? And merge into basically does not only insert the things, but it, yeah, more or less we're looking at upsert here because we are updating and we are inserting elements that are coming from the statement below. So let's go ahead here. So the solution here that we can use is our own upsert procedure. So you probably know this from our replication jobs. Whenever you want to replicate a table and create a replication job on it, that there used to be probably in some of your versions it's still there. There's it was only able to, at least via the wizard, was only able to put the data into the analytical storage. Now you can choose the destination. These sources are not writable. These are our community databases. We're also going to share them with you, so they're not writable. If the data source is writable, it will appear here. And this has been the case for if you use the procedures directly, that has always been the case. But people were probably not aware of it. And I also requested that our documentation will be updated. And I've seen it, it's already changed, and we just need to deploy it. All right, so it's possible to upsert to any writable data source, not only DWH, and now also in the wizards. So when we are creating the job, the definition will be an upsert procedure call, right? If you create this with a wizard, you're basically creating a procedure call. So there's nothing stopping you from doing this procedure call on your own. And these are the parameters as they present themselves right now. As you can see here, it used to be a parameter DWH table, but now it's source table to make it more clear that it can be anywhere. Here we are also not using DWH in our example. Here we are using an array to pass the parameters, the key columns there, so you could just list them. The update columns are the ones to update. So you might also want to exclude some columns. That's possible. Here I'm using a combination of these two things. All right, I'm using the same ID I used before, and I said invert the update columns. That means please update all the columns except employee ID. That saves me a lot of time typing all the different column names here. Sorry, I was talking about the source table here. That was always the case. I'm talking about the target table that used to be DWH table, but now you can use basically any writable data source that is connected. And some additional options here. So some surrogate that you can create. If you're putting data together from different sources, you probably want to have a leading ID. And this is what these two parameters are doing. And then finally, you can also use the upsert procedure for this to check the maximum field. And here it would be modified date, but of course, a modified timestamp makes much more sense. And this basically the upsert process. If you're using check max field, it will always look at the target table, which is the highest modified date there, and will get data from the source only with a modified date higher than this, also meaning a low footprint here. And then there's a default value for this check max field. All right, so you can simply use this exec utils.upsert instead of the merge statement. And our clients have been successfully implementing their merge into statements with that. Yeah, so there's not much more to show here. Are there any questions, Carlos?
Yes. Someone asked about the invert update columns. It wasn't clear how it should be used and what the purpose of that is.
No problem. It makes more sense to look at this probably in the wizard. So let's take a look here. All right, with my upsert update, right? For me, it's always better to show this in a graphical way, so that probably will help you. All right, so I'm creating this upsert replication, right? I'm choosing my target data source, my target table, and now it's basically, there's two parameters here. And one is the key columns. That's basically for my sales order. It's probably the sales order ID is the one that identifies a row uniquely, right? Because of course, for upsert, I want to know, is it there yet, right? Are we there yet? Is the data already in? Is a row with this sales order ID already in? If not, please insert it. If yes, please update it, right? So that we need to identify the keys here. And now what would I do when I say I want to do all of them here? So I basically have to click all of them, and you can see it's already getting boring, how cumbersome this task. I'm not even finishing that, right? Because it's just taking too long. And if you imagine this being a procedure call that I'm having to write here, I would have to list all of them. So what I'm doing is I'm removing all of them, and then probably it becomes much clearer when you see this. Just clicking the same one, invert update columns, and that basically makes not operation. So if it's true, it becomes false, and all the ones that are false become true. So I'm basically implicitly selecting all the columns except, of course, the sales order ID, which should never be updated. And when we finally finish with this wizard, just give it some arbitrary schedule. And now if I look here for where is it? The upsert update. That's exactly what I'm looking for. And now if we look at this, what's happening internally, we can see that this the system actually generated a stored procedure call to it, right? So there's nothing, it even created a SQL job from that. It's not a specific job, it's really a job that executes some SQL at a certain point in time. And you can write here whatever you like. And of course, you can write also things that you cannot reach with the wizard. You can also have multiple statements here, and to probably to make it a little bit more readable here, how we can see exactly the parameters I was showing. So I hope that answers the question. All right, are there any other questions?
Yes, there's one other question. Typically, upsert replication is done in a job, and one of the participants is asking if it's safe to perform this update through a statement that is not part of a job.
Yes, that's absolutely the case. Yes. So that's probably this is exactly the why we chose this article. That's exactly something that you can use, and you can just use this as if you were using an insert statement, right? And the only thing about this is we don't have the merge statement, so you can use upsert, and yes, it's safe to run this on demand outside a job, not a problem.
Should they be, do they need to be careful to check to see if another upsert job is currently running to make sure that they don't run it at the same time?
It's a good idea. I mean, always. You might run into transaction problems, but it also might get queued. That really depends on the target system. So our server is not checking that there is another upsert running. This is something that needs to be manually checked. So that's really a good question. And yes, that should be checked.
Thank you, Matthias.
All right, perfect. Okay, let's continue with our topics here. Okay, so stored procedures. So we want to pass key value pairs to a stored procedure. The limitation here for the stored procedure is always you have to provide named parameters, right? So you can give a parameter a name, and then you can pass on this particular name. But it might be limiting, right? Just as with NoSQL databases, you probably don't know what you're expecting in terms of parameters. So what you can do here is pass on key value pairs, where you basically have as a key the name of the parameter, and as a value, obviously the value of the parameter. And let's take a look at our stored procedure and what we can do with this. All right, let's read through it. We can see here, now we're getting two in parameters, and one of them is object. Let me just annotate here. So one of them is this parameter object. The other one is not mandatory. It's a key parameter. We're going to take a look at this later. And it will basically, yes, return the number of the argument, the key, and the value. So what we're doing here is not calling a procedure with these key value parameters, but we are parsing them, right? So we're getting them out of the parameters that are supplied. So let's take a look at our stored procedure definition here. So first we are declaring a counter, setting it to 0. And now we are doing something that we are mostly also doing in our connectors, actually in the SQL connector, whenever there's paging involved. And as a variety of other scenarios, you might also want to share some of them in the community if you find any. But here what we're doing is create this local temporary table, and this one actually exists in memory of the server, right? It lives as long as the procedure lives, so we need to do something with it. Either we, as you can see down here, to return something, we select basically from it. So the values of the temporary table are selected eventually and returned by the procedure. And now that we've created this local temporary table, we are looping through the parameters length. So we're using the array length function on this params object. And then in the loop, we are basically doing this here. This is the part of the loop. We are inserting the first key and then the first value. And you can always see this with the, so we are increasing the variable here. We're giving it, it used to be 0, and now we're adding 1 to it. Each time in the loop, we're increasing it, putting this as argument number, so they are counted, and this is something we're going to return, and we're going to yeah, first we're going to put it into the into our temporary table, and then as you can see here, first the key that would be of index 1, and then one index next to it, of course, would the value would sit there, and there we're finally increasing the variable to stay, and then we're going to the next one. So we're actually looping through all the objects in this nested array, and it will be much clearer if we take a look at our at how we call this. But I just wanted to explain how we're working with these key value pairs internally. So we're working with this local temporary table, inserting them, and based on the parameter, we're changing our output. So if a parameter key is supplied, we're selecting this one with a filter on key. And if this key parameter is not supplied, we're selecting everything, returning everything from this temporary table. And let's now take a look at our, just close that. Yeah, now we can see here some of the examples. This, sorry. So the first one is basically two arrays that we are nesting in an array. Same here, and here we're using the key, but let's take a look at this in our studio. Okay, and you will we will publish this source code on GitHub, and you can just download and run this on your server and take a look at all the implementations that we did here. So the first one is our stored procedure. That's exactly as we saw it in on our slide where I was explaining it. And the next ones, these are also interesting concepts here. So what we are doing here is I wanted to provide this to you, and the example here is just the call only, but this is something that I cannot publish to you, right? So I needed to create a view from it, and we can see here the nice bridge between a select statement and the call to a procedure. That would always be your possibility to create views based on top of procedures where you put in the parameters in the view. And again, this is something that we use in connectors. For example, if we have some example calls for connectors, we are providing you with a set of views. But now finally, let's run this thing. And now we basically see the key and value for each of them. And this parser now you could use with other procedures. If they are getting parameters in, you can make a call to them and unnest them, and then basically loop on the result set, for example. That would be one possible application on it. And if you want to search for a key, here we are giving the parameter key, which we set to the value master. So it should return master class. And let's take a look at this. And now only the master, the value with the key master and its key is being returned. All right. Are there any questions right now, Carlos?
No questions at the moment. I was wondering, is there any particular application you would suggest using this in?
Yeah, it's not a specific use case I can think of right now, but it's usually when you don't have a defined set of parameters, or you don't want to write in here, right? It's the problem that we're tackling is that usually the parameters are always static, right? Imagine this key parameter here being a static parameter, and I cannot overload this to have multiple parameters. Yeah, I just can't, and this is the possibility to pass in these key value params, and they could also be originating, for example, from other tables or from a REST API call. So it's a very open thing to use here.
Okay, thank you, Matthias.
All right. Okay, so let's continue with our presentation here. All right, the regular let me go again. Regular expression replace stored procedure. All right, so it used to be a problem in an old version. So this is a fairly old request also, but I still want to share the contents of you for you. So we didn't have this regex replace function in Data Virtuality, and people were asking for it. So the solution here, and we could stop here, the solution was a feature request. Again, pointing back to our initial remarks on if you want to see a cool feature at Data Virtuality, just put in a feature request. And we definitely are going to answer this, and we will take this on our roadmap here. So we are really letting the community decide what features are coming in besides our roadmap anyway. And here you can see this completed thing, and we can actually still take a look at the article that was there before this community request was created. And let's take a look at it. All right. So here we are using JavaScript with object table, and Carlos is going to shed some light on this and provide you some details of this with his track next. And let's take a look at it. Okay, a stored procedure. Here we put it in the demos schema. We called it regex replace, and then the three different parameters. So the string that is to be replaced, then the regular expression of what is to be replaced, and then the replacement basically of what it shall be replaced with. Of course, this returns the result set. And here now is the definition, right? So we are just using object table with the language of JavaScript. Regarding that, it's interesting to know for you, probably we have Python on our roadmap as well. It used to be a problem with the versions of 2.3 and before of Data Virtuality because they were with an old Java version, and we could not really find a library for this Java version, but this has changed with 2.4, and so the development actually took up some speed. So we're going to see Python here as well soon. And it's basically very, very short call here. We're using this Java lang string class constructing with initial string. So we're passing the parameter through initial string as initial string. And then we are on this string object in JavaScript. So it's not really Data Virtuality, it's really JavaScript right now. And on this one, we are using this replace all function. So we're suddenly opening up the box of all the features that are there in JavaScript that can be extended to use in Data Virtuality. Okay, so fairly simple call is one line, and then we just need to pass on the different parameters and the result set that we want to retrieve. And as we are calling this then result string, this is basically the one that we are returning. All right, again, we are selecting from a procedure call, so we need to put an alias behind it. And finally, then our procedure is finished because it actually, this is the return value, the select, and then simply ends. And here we have some example of how to use it. So let's take a look at this in our studio. Okay, regex replace, here we go. Okay, the procedure itself, as we talked about this already. And now the different examples here. And this is the one that we took a look at. And it's interesting. right? So here we are using an interesting combination of things, right? Because we remember that the procedure itself, it only took one parameter, right? But here, we in our example, we are actually using a select from sys.datatype. So if we do this alone, let's just do it. That would return all the data types that are familiar to the data virtuality server, right? So it's basically a table for us. And what we are doing here is we are using this, this way of calling a stored procedure with a data set. So the stored procedure will actually will be called on each of the rows, on each of the rows of the sys data types, and will process the result there. And we are using k as an alias here, and we're using k.name. So if we jump back to it, name is always this one. And here we are now making the call internally. Initial string is k.name. The original k.name put beside it, passing the k.name as a parameter for initial string. Then our regular expression, this one actually only uses all the vowels in the English language. And we will replace all the vowels with 2 asterisks. So let's take a look at it. And you saw it did a little bit of processing, right? And here you basically see all the entities. You see here the E being replaced and the I and so forth. So that's basically this simple example here of using regex replace that has been implemented with our stored procedure language and with object table and JavaScript. There's already a regex replace function in data virtuality. And let's take a look at some other example here. So here we are creating a table from rows that we insert, and they are basically JSON. So let's take a look at this one as well. So you can see how this is being transformed into a table using the object table function. And finally, here we are using the reverse function. So we are again using sys.datatypes as the data source, and then are calling this reverse function inside JavaScript, and that would basically just split the string and then reverse and then join it. And let's take a look what this shows up here. Right, so this was an implementation where we would just have name and then the reversed version of it. And these are just, again, some examples, right? So probably not something that you would use on a daily basis. Also, since regex replace is already in implemented functions, but they just are supposed to show you the different options that are there. And if we look further here, I provided a link to you to this JavaScript reference, and this is basically now all open for you, right? And here we were using the regex class, but you can also use all the string function. So whenever there's something that you're missing, if you are only missing it one time, then you can implement something in JavaScript. If you're missing it more than one time, it's time to put a feature request into the community again. And yeah, it's basically everything that's here is available, all the escape sequences, all the different functions. Yeah, so I'm not going to read it out here, but yes, the whole JavaScript language is available, and Python will be there as soon as well. All right. Are there any questions, Carlos, on this? Okay, yeah, so I can see the questions here. So yeah, so the JavaScript functions, it's actually a Mozilla engine that's under the hood. So everything that works in a browser should work on our side as well. And other JavaScript, other languages than JavaScript are supported. So yeah, go ahead, Carlos. You want to answer this live? Oh, it's already answered. Okay. Oh, this is answered live, exactly. And the timeline for Python, I would have to get back to you. So I just took a look before we started with this session. I took a look, and it's actively in development right now. And I can update you on this later on. All right. All right. You have to be careful here because, of course, this will consume a lot of resources, right? So if you are, for example, doing what I did here with this regex replace on a hundreds of millions row data set, of course, it would use this engine to process each of these rows here. So it's a performance consideration as opposed to operations that we can push down. So native functions on data virtuality, if we know that the data source supports it, we are doing a push down, meaning we are executing this at the data source. And of course, these data sources, they are much faster doing these things than we are. The native function is always to be preferred. But if there's anything you're missing, you can still do this with the stored procedures and object table. All right. Okay, so application of stored procedures in our util schema.
Oh, Matthias,
Go ahead.
we have one more question about regex replace. Is regex replace translated or implemented as a native function?
It should be. So it really depends on the data source, right? So imagine we have more than 200 connectors, and we would need to check the availability for each at least of the data sources of the database data sources. So it should be, it might be. I cannot speak for all of the databases. For the major ones, it should be. But it's also something that as a little task for our community to find out, I can also get back to you, and I will add this a reply to this. So Carlos, please take a note of this question. I will add a reply to both of for the timeline of Python and for the push down of regex replace. I will answer them here in the slides and then publish the slides to GitHub, and you can find the answer there, or just drop me an email if you want to know it and I forgot it or something.
Thank you, Matthias.
All right. Okay, let's go to our next topic, and that would be the application of stored procedures in our util schema. So, yes, not all of the utils functions are known to our community. They are documented here. So there is a list of them, and it makes a lot of sense to really go through them. There are gems here like unzip, where you can just unzip a file, for example. And it's also something that we noticed in community feedback and support requests and in our projects that not all people are aware of it. So the list itself can just be found here. System schemas, utils, procedures, right? And if you, it's documented here, it's documented on our documentation. And if you want to know about the parameters, you don't need to guess. You can just simply double click on any of them, and it will tell you the parameters. Probably this was not a big example here. Let's see one with a larger set here for CSV export. You can see all the parameters are described. That's a small documentation, and if you need a larger one, you can also consult the documentation. Now, I picked some examples. So let's take a look. All right, so we want to get a table from an array. We want to create a table, as we don't allow create table from the data virtuality syntax. We want to convert a table to JSON, and we want to avoid casting problems. So let's take a look at these things live. And that would be utils highlights down here. So let's take a look at them. Okay, array to table. So that's very simple. You just call it, you pass on the items here. So again, it's since this is an array, it's an can be a list of elements, but not key values. You would have to do something else there. And let's just run it. And so we see this is now just simply returns a table where each row here pays respect to the parameters that we passed in. All right, another one that might be interesting for you guys, since you know that's there's not possible to use a create table statement from data virtuality. Actually, these is also some kind of background here where a lot of these utils procedures are coming from, to also have an understanding how our development works. Is that I would guess a lot of these have been requested by our connectors department, because it's difficult for them to emulate all of this stuff using JavaScript that we don't have. So they are doing internal feature requests, and there are then these new functions are being created. And this is also the reason why newer connector versions might require an update of the server. That's exactly the reason. So if this is being used in a REST API connector that we provide, of course, you need to have the server to have this function in it for the connector to run. That also gives you probably a little bit of insight how the relation between server updates and new connector versions is working. It's not too often, but it still happens. And let's now just create the table. So this is the table name here, underscore table name. These are the columns and types, right? Listed, separated by pipe. And then let's just run this. So I'm selecting from the view, which is internally calling a procedure that does something with fixed parameters. Again, this nice bridge between view and procedure. And now it returns to us just the table name. And if I take a look here, it's not there yet, but now it has been created, and we can see that it's there with the data types that have been requested. So that's an easy and quick way of creating a table without having to use the native function. The native function of a data source would also be an option to just use here MySQL.native, and there I could go ahead and create table, but then I would have to use the syntax from MySQL. So let's close all tabs here. And let's get back to our utils highlights. So the next one would be table to JSON. And again, this is a beautiful thing. Before this one existed, you could create JSON documents from tables, but you would have to go manually, right? You would have to iterate over all the columns, over all the values, and then create the JSON manually around it, but not anymore. So what we're doing here is we are using my MySQL.sales person table, MySQL salesperson. Let's just take a look at it. And we basically want to have this one as a JSON document. So let's run it. And now we can see it's not nicely formatted, but it's exactly the JSON that corresponds to this table. And there, for example, you can send it as an email, so that is something that can be applied in various things. You can save it as a file using also the save file function here. So there's many options here to leverage the creation of JSON, and there's also an XML version available. So you can simply convert a JSON or an XML, a table to JSON or XML. And finally, the last example here would be our TriCast, and there's also different versions available for this. And this one has one simple advantage here: it doesn't throw an error, right? Usually, when you cast something and it's not in the right format, you would get an error message. The whole thing, the job would abort, or the procedure would abort, or your view would throw an error. But with this TriCast, you can actually see that it's not aborting, but would just return null here instead. So here we are trying to convert ABC to a decimal, so that's definitely not going to work. And the result we're seeing is null. So as expected in the error case, and if it's something that works, it would just return the value in a decimal. All right. Okay, so are there any questions right now?
There are no questions at the moment.
Mm-hmm. Okay, yeah. One remark I see here: regex replace did work for me in the latest version of DV. Yes, that's exactly right. It was an example that I still wanted to show you for some implementation using object table and JavaScript. There is a regex replace version, and you can simply use it. All right. Let's go to our next topic here. That's moving tables across servers. All right. Okay, so there are some use cases for this. For example, if you are moving to a different analytical storage. So that's also some insight from our solution engineering experience, is that people start off with things like Postgres, and then they see there is a limit, right? The more data you provide to your data consumers, the more data they want to have. So the appetite comes when they're eating, and that at some certain point, Postgres is not enough anymore, right? It's a disk-based system, and there are analytical storage that have a higher performance, such as Redshift or Snowflake, MemSQL, now Single Store, things like that. And you just might want to update there to them, but how do I get the data across, right? If it's the same database type, right? Now we're talking about the solutions. If this is the same database type, so for example, you want to create a second server with an analytical storage, and you want a clone of this database to use Data Virtuality Sync between a production and a development system, use the database capabilities. That's my tip, right? You have both databases available. You can just back up and restore it. There's no need to do this in DV, but this is only true if it's the same database type. So if the tables are not too large and by too large, I mean you will just see it. If you try the select into approach, you will sometimes see that this tables will be locked in transactions, or some error message. You might see that there's a too long loading on this system. And I'm talking about probably hundreds of millions to billions of rows that might just be too large to query this in one result set and be able to stream it over. And that is the case. We have another approach, loading in chunk. So let's take a look at them. All right. Here we are looping on the metadata. That's now, it's, even though it is a very short snippet, it's still interesting what we're doing. And we are using select into dynamically for each of them. So we're doing a lot of stuff here. So let's take a look at this. All right, it's just a block. So you can just also execute a block without having a procedure around it. If you want to use the stored procedure language, you can just use, for example, a loop in a block. And so we are looping on, we are creating a cursor on everything from systables, where schema name equals DWH, right? And systables, if you're not aware, contains all of our metadata available for consumption using these tools. So for example, systables here would show me really all the different tables that are present on my system. And that includes, for another example, I set up a job that constantly creates stages here, so mat table stages, but as well all the other, also the views. You can see them by type view here. So everything that our data virtuality server knows in terms of data, of metadata, is available in here. And this includes all the objects that you can basically see here. And we are now leveraging that. We are now looping on systables. So we're making a call for each of the entries in systables where schema name equals DWH. So that's all analytical table names. And we are calling them DWH table as an alias. And then in our loop, basically inside, we are using, and now it's the second great concept, I think, execute immediate. If you are not aware of it, this is an option to create dynamic SQL. Why can't you do this all the time? The problem is here that we are also working with metadata. And we have to work with metadata. And this one is basically excluded from metadata checks, right? It's not a view that is included in the dependency system or in the lineage. It's really something that is just fired away, and execute immediate allows me to concatenate in here the table name, right? DWH table is one row, and name is the name of the table here. So if we read it in the end, select select into. So we are creating the table in the destination, putting it into our data source DWH new, giving it the name, and then we are selecting from DWH table name, meaning for each of these loop runs, we are creating a select into statement that would then copy the table from the old DWH, from the old analytical storage to the new analytical storage. And that's a very nice and small snippet that uses many, many concepts of data virtuality all at once. And this is something that we usually would put out from our support. When someone is asking, we want to move to a new analytical storage, can you help us copying the tables? We have a kind of similar solution here, but this is rather for backing up. So you can also use this to create backups of your analytical storage tables. If you don't, for some reason, don't want to use the backup functions of the data source itself, or it's something that is hosted and you can only do snapshots of the whole data, but it's too much. There might be a couple of reasons to do that. So this is the solution to copy them one by one. There is a little problem here that I was mentioning in the beginning. That's this select into. It reads the whole table, right? And if we are talking about billions of record sets or hundreds of millions, it might be a very slow process, and it might, because we need to read and then we also need to write on the other side. It's not only that we want to get the result set only, but we also constantly need to push it to the other data source, to the destination. So this might run into errors with larger tables. And so I just copied one of the solutions we gave or we implemented for our clients. And here we're also doing different concepts all at once. So let's take a look at this. So here we are declaring a job ID. And this job ID is being returned when our system is told to create a SQL job. So you don't need to use the wizard for it. You can also do this dynamically, create a SQL job with different parameters. So the parameter here is the script. And the other parameter is the description. So we are creating a job with a description, and this is a chunked loading of data. Here we are working with the specifics of the table, so this is not a general thing. So we knew about the size of the table, meaning we knew that we could, this was, supposedly 40 million record sets here, less than 40 millions. And again, we're looping over this variable and are inserting into the destination from one of the views. And here we even transformed the data before we copied it over. And yeah, all the other details are basically then here used to get the certain chunks. All right. Okay, so this was the large data set example. So are there any questions right now? Okay, so Carlos is busy answering. I like that.
Oh, sorry, I was on mute.
No worries. No, I can read the questions anyway.
Okay.
Okay, so Carlos, you're replying to the first one. So there is one by one of my favorite customers. Do you suggest adding a new DWH as a data source since we can't have? Yes, exactly. So here we are also leveraging the fact that we can write to data sources as well. So data sources is probably not the right term, it's data destination, but it depends a little bit. In the later versions here of Data Virtuality, you would actually see for the writable sources, you would see an indicator, and that's importer.default. So this is how I can make a data source writable. And I hope this will work right now. Even though this is a read-only user, but to make it technically possible for Data Virtuality to write there, let's just see here. We can now see in the later versions, now we see this green arrow as an indicator that this is a technically writable data source. Doesn't check the permissions at this point. And that's exactly true. Regarding the question, yes, you would connect this as an additional data source. It's really, when I see this as a development at Data Virtuality, it's less and less really locked into the analytical storage as a destination, right? We started with only this being the only destination for replication jobs. We talked about today how replication jobs can now write to any data sources. From my point of view, the analytical storage now really serve this one purpose and only, and that's the destination for materialized tables. There's much more possible with it. It's your playground, right? You're not working with your transaction systems. You're not creating tables next to the production tables in your transaction system. It's a playground for data. But other than that, there's nothing stopping you from writing into data sources as well and using them as a destination for data to make data virtuality kind of a platform for data where you can write it arbitrarily. And yes, so the answer to the question is yes, it would be added as a data source, and there you can copy it over. There will probably, at least I don't see it in the future and on our roadmap, that we will support multiple analytical storages. All right, let's move on to the next one. So Carlos will say the complete opposite in the next track, but for us, we don't need static tables for date access. Again, this is something where I just want to give you some practical snippet that we use from time to time. It doesn't mean that you don't have to use a static date access table. So date access, it's exactly what you're expecting, and then what every ETL developer knows. They want a date access to not miss some of the dates where they don't have data, right? They still want to see this on the plot. Tools like Tableau do this automatically, but still you want to get your data right. And that means you want to have a date access. And this one, this procedure can simply be used for this. Let's just take a look at this. Date access, where are we here? So here's the procedure itself. We know this already, right? We know a temporary table in memory. We know the looping, and so it basically loops from start date to end date, and then just insert each date, and then the running date here is just incremented by 1. So it's always current day plus 1, next day plus 1, next day plus 1, and finally returns the result to us. And to see this in action, we have this date access demo here. And the beauty of this one is I don't have to curate my tables, right? It's always goes until today. If that is a use case that you have, you don't need to fill it or watch out that you don't have the latest dates in there. This function or this view here, again, a bridge between view and procedure, will always return all the dates from the first of this year until pretty much today. So yeah, since we're low on time, yeah, if there are any questions, let us know. Otherwise, I would just continue. All right. Drop alt materialized tables. So we used to have this problem here. It's not actually a problem. This job has always been there, right? You are aware of this of these system jobs that are cleaning out the cleaning up the system all the time. And this one, the clean stale replicator table task, cleans away alt met tables, and you can edit it to keep stages, and you can also keep it for days, right? You can say, I want to keep 5 days worth of data in materialized tables, or I want to keep 5 stages or something like this. To have a more granular control over it, we can take a look at some of the procedure. Or here again, it's a select statement only. And this one is doing a lot of string transformation. So it's basically picking up from these table names. It's picking out the met table, the stage itself, the priority, using a window function. Carlos is going to talk about window functions tomorrow, I think. So we're not going to dive into this too deeply. And let's take a look. Drop alt met tables. Here we go. So the first, the view probably. That's exactly the view that we saw before. And I created a replication, a materialization job that runs every day, every minute here. And this one produces stage tables, and we can see here the latest 10. This is actually what our select statement returns. Right, so it returns the 10 latest stages, and these are probably the ones you want to keep, but it's really up to you to work with that. And if we put this together, let's probably make it a little bit more readable here. We are creating a stored procedure here that deletes these stages. We can provide a parameter of stages to keep. We are already working with error. Yeah, we are raising our own error handling here, right? It's not not handling an error, we are raising an error. Also something that you might want to do in your procedures to keep up make them robust against the wrong set of parameters. And again, here we are looping on the data that we just saw. And then we are finally dropping these tables. So again, we're using a cursor. So we're using loop on. We're creating a cursor. So the result of it will actually be all the tables that are not the ones in max stages to keep. And then we are again using our execute immediate to drop all of these tables manually. So it's, well, you still can use the materialized table clean stale replicator job. There's nothing stopping you from this. If you want finer control, you can do a lot more with this procedure. And yeah, you can actually get the source code from GitHub. I will share it there. All right. Okay, so could you, there's one question regarding, okay. There's one question regarding how to make the data source writable. So I was doing this very quickly in order to just show you the arrow here, but let's review what settings I did here. I was actually just adding one parameter, and this is, for our system, you have to imagine it needs to know where to write, right? For reading, it's clear. I have here it's this schema. I also have probably some more important options like schema pattern. So I can actually have multiple schemas in one data source, right? In my Postgres, I could refer to 3 different schemas and list them all using full schema name or not. But when it comes to writing, the data source needs to know where to write in what schema. And this is exactly the parameter. And if I put in this parameter, it basically tells the system it's got now all information it needs to potentially write into the data source, and it would write into the schema dblearn MySQL. That's the only thing here. All right. Okay, another practical snippet here is finding recommended optimizations without a schedule. Right, there's an article about this. Enabled recommended optimizations. What is happening? Let's go to our optimizations. So we did create some here. So for salesperson, I enabled it and I materialized it. For sales order header, I enabled it, but I never materialized it. And it might also be that you don't have a job that updates this data. So in this case, it's even worse, right? I'm I'm creating a shadow copy of a data source table, but I'm never updating it. But people or users, they are using this table. They are addressing Postgres.sales order header, but they might not be aware, especially if they're not using the studio. So the studio will most of the time tell me what's going on, right? I know about the age here. But if you're not using the studio, for example, or you just have too many of them, it might be a great data quality check thing to check if all the materializations have a schedule that updates them. All right, so we can use, again, DV's metadata to identify the materializations or the recommended optimizations that have been applied but have no job to update this. And find records without a schedule. Here we go. All right. So what is this thing doing? It selects something. So it's using, again, this time it's not using the sys schema, but it's using the sysadmin schema. And in sys.recommended optimizations, you would find all the existing ones. So this is exactly the same thing that we are seeing here. And there's also a flag down here that says enabled, right? And the ones that are enabled are written down here with true. So this is actually one part of the story. That's the applied ones. And now we are then using sysadmin.schedule jobs and schedules. So the jobs and their schedules join the two things on their group ID here and their job ID here to find where it's enabled. But for the schedules, there is no schedule, right? So we are actually picking out the ones enabled, no schedule. And let's take a look at this. Here we go. And it did find exactly the one that I was talking about, the sales order header, where I just arbitrarily applied it. I can just enable here, right? And it's dangerous because I can also do this one. I can run them now, right? But in the end, if I don't create a job for it, I don't see this anywhere. And this can be a nice data quality check to, you see them more and more coming up here. All right. Okay, so there is a question to connect to 3 schemas, and that would be, let's take this offline. Carlos, please, or Carlos, you can probably take this. You can reply to this, right, with schema pattern.
Yes.
Okay, perfect. All right. And now the final thing you've all been waiting for, optional joins. Some of you might be aware, others might not be aware. Okay, optional joins. We learned this when we were dealing with a client who had huge BigQuery data sets, and they were joining these tables a lot, and the sheer size of the data sets and also the structure that they had made them join everything with everything. And the problem there is you might still just want to select one of the columns there, or a couple of columns that are only present in some of the tables that are joined, but not joined in all of them. All right, so let's take a look here. It's hidden in the documentation. And let's reduce, or let's talk about the problem again. Okay, so a view that we created consists of table A joined with table B. The users, they query only fields of the table A. You can, of course, extend this to as many tables as you wish, right? And the join to B will then still be executed, right? Because we are, the view is a join, right? So when I'm querying something, then the whole join is executed, even though I'm only reading from one table. And this is, especially for a large data set, might be really a challenge to get a hold of that. And the performance will go down drastically, even though you're basically selecting from one table or only a couple of joins, but not all of them in the query. But for your large queries that, yeah, very wide tables as we know them from ETL work, because they contain all the possible combinations, you want to declare the join as optional, so that if I only query fields of table A, the join is not being performed. And you can do this by the optional statement. So let's take a look here at the query that I'm using. That is actually product.name coming from the product table, and the other ones coming from the other table. So it's pretty much as we expect it to be, right? We are selecting, we are joining them, both table information is being needed. So this optional parameter doesn't change anything here. However, if I now omit the query to the product table, we can see that now the system is not joining the tables anymore. So our relational planner, our planner component that creates the executes the queries on these different systems, would actually only need to select from one table, right? And this is, of course, with large data sets, and especially as we saw this on these huge BigQuery data sets, can dramatically improve your performance, of course. I mean, it's almost obvious. And even though this is not a distributed join that's happening here in this, or was happening in this particular client, still this is something that you need to consider. And I recommend using this, especially if you have joining larger tables and you don't know in advance what fields are being queried by the user. Of course, the user input can even drive what kind of join is happening. All right, so we have a little bit more time for questions. Are there any questions here?
There was one question previously about, oh, sorry, there's a new question. Why are joins not optional by default unless stated otherwise?
That's a very good question. And there's some danger. I didn't put it in here. The problem is that these, if you start counting the results, for example, you might get wrong results, right? It depends basically on what column you're counting to influence what the number of data sets in this result will be, right? So it's something that we want to give you control over. And yeah, it's a decision that the developers made basically. And yeah, that's the reason, is that there's a little bit danger, for example, when counting this data. And also the predictability is different. So it's something that you need to explicitly state. There's another one that Carlos, you can probably take a look at. I want to go into my summary now. Our community and help center offer a variety of solutions, but they're often overlooked. And sometimes it's just that you don't know. You see an error message like in the beginning, right? You look at this CSV wizard and it shows you some error message, but you cannot probably not connect it to the community solution. This is why we had this session, and it makes sense to browse them. At least take a look at them, browse them. We also have, in regards of education and community content, we want to do a lot this year. And so there will be new content arriving as well. Be sure that you subscribe to the topic so you get an email if something is happening. And now, only for the 10th time today, share. If you create something nice, let the world know in our community forum. Yeah, so that's basically it. And yeah, if there's any other feedback and questions, go ahead. Otherwise, let's go into our break.